Hello world and welcome back to Money Makes Games. In this fourth video in our 3D Spider IK series, we're going to do some ray casting to ensure that our spider keeps its feet on the ground. So, if you're ready to do some terrain detection, then come with me. My name is Mani and I make games. To understand how we're going to do our terrain detection, I've used my tremendous art skills to draw some spiders. Of course, if you believe that I need to go back and get some more art lessons, I would encourage you to hit the like and subscribe buttons to help me afford that. Now, let's have a look at this. In our first picture over here, you can see that our spider is heading downhill. So, the ground is here, but our foot placement target, which moves with the spider body, has ended up here. So what do we need to do? Well, what we want to do is we want to take a point above the foot placement target and cast a ray right down from here. As you can see, if we only cast it to the foot placement target, it's not going to hit anything. So we'll cast straight through and we'll get a point here where our ray actually intersects the ground. And this is the closest point that the ground is going to be to our foot placement target. And we will move our foot to this position instead of going to the foot placement target. If you look at our second picture over here, you'll notice that when my spider moves forward, the foot placement target intersects with the terrain. Now, right now, the collider hasn't hit the incline yet, so the spider's orientation is still going straight down. So our cast will be coming this way and going towards the foot placement target, and before reaching it, hit the ground and setting our new target for our foot placement to be slightly above the foot placement target. The last illustration here just shows what happens when our spider is already walking uphill. So basically now we need to cast from here and not here. If we used transform.up with a negative value, we would have cast straight from the world up down. Now this is fine at this angle, but imagine a steeper angle. So what we want to do is use the body transform.up or the transform.up of our foot placement target and cast straight down from there until we hit the ground here and set that as our foot placement target. Now how's this going to look in practice? Well, let's go have a look. In practice, I've taken my spider, I've selected all the foot placement targets and reset their rotation so that the orientation of these actually match the parent. That makes it a lot easier because now we don't have to keep track of the parent transform, only the transform of the foot placement targets, which will move with the parent. Then, on each foot placement target, I've placed the terrain detector script, which we're going to go through now. And because we are going to do ray casting and filtering for certain layers, I've gone to the terrain and I've added a new physics layer called terrain. Now this physics layer is only going to be assigned to objects that can actually be hit by my terrain detection raycast. Then we go to terrain and make sure that it's assigned the terrain layer. In our script, you'll see that I've set up some variables, which I'll explain as we go through the script. And one public function called getHitPoint. So in getHitPoint, we've got array cast hit that we've declared to store information about the hit we're about to get. Then we declare the array that we want to cast. Now, looking at this, you'll see that we need the array's origin, which is where we're casting from, and we need the direction for the array. Now, the origin is basically the transform.position of our terrain detector, in this case the foot placement target, and we've added to that the cast height in the direction of the transform.up of this specific foot placement target. Then we're casting the terrain, we're casting our array in the direction opposite to the transform.up. So if we look at our sketch here, transform.up in this case would be this way. So our array would be coming from here in the opposite direction like this. We've got our cast position, we've got our direction for our array. Now we go physics ray cast. We take the array, we cast it, we store the hit in hit using the out keyword, and then we set the distance for our array cast to cast distance, which I've set up here. That's basically how far we want to cast our array beyond the foot placement target. And then we add to that the cast height, which is the height above terrain, and we filter to only return hits for terrain layer. If we look at this, why did we add the cast height and the cast distance? Well, the cast height basically says this high above the foot placement target is where we want to start our array cast. And the cast distance is how far beyond this do we want to cast. So if our spider was cresting a hill and he was getting to this point here, we would want to cast, and if this point is actually too far for the foot to reach, we don't want to get a hit from there. So then we would rather go to our default behavior and put our foot up in the air, which I'll explain now. So that is why we have a limit to what our cast distance is. If we didn't add the cast distance and the cast height, we might run into a situation where we set our cast distance to a value less than the cast height. So let's say the cast height is 4 units above where our foot placement target is, and our cast distance is only set to 2. That means we're only going to cast halfway down to the foot placement target, which means that if the foot placement target is not underneath the terrain, we won't get any hits. Now, if we get a hit, we check the collider on our hit. If the collider is null, that means there was no hit. If the hit is valid, we take the hit.point, which is the position of the hit, and we set hit pass to that. Else, we are going to set our hit position to basically the cast position. Now, this is a default behavior I've set up for my spider. You can do whatever you want in here. In my case, this is just going to cause the foot to go up into the air, like the spider is feeling around for something. And then finally, we return the hit position. Now, where are we returning the hit position to? Well, whoever's calling this, and who do we want to call this? We want our foot script to call this. So in the foot script, nothing much has changed. as you remember, we already have our foot placement target here. We've declared a new variable called terrain detector, in which we'll store the terrain detector on our foot placement target. And we get that in our start. And then an update, when we get to the top of our step and we are starting to look for our final foot placement position, instead of saying just placement target dot position for our final foot placement position, we now query the terrain detector on the foot placement target and get the hit point, which would be the closest terrain point to that foot placement target. Finally, back in the editor, we check that all our foot placement targets are filtering for terrain so that we don't miss any hits, and we test. Let's find some uneven terrain with a sharp change. There we go. And finally, we have some terrain detection. In the final video of this series, we're just going to tune the walk cycle to make it look a little bit better and check that our spider doesn't fall over when it's going up a steep incline. Until we see each other again, my name is Marnie and I make games.